Hi everybody, I'm Tim Stevens and welcome to a very special discussion with representatives from all 5 of the Milestone prize winning teams in the Google Lunar XPrize. Now, what is the Google Lunar XPrize? Well, it's a race to the moon, and I could explain more, but we've got a very fancy video that'll do a better job than I could, so let's have a look.
My name is Andrew Barton, Technical Operations Director for the Google Lunar XPrize. The Google Lunar XPrize is a $30 million prize to land a robotic spacecraft on the moon and move across its surface. The total prize purse is $30 million, and that's the largest incentive prize ever. The Milestone prizes were introduced to give teams a boost in their preparations towards liftoff. The Google Lunar XPrize started with over 30 teams. Now we're down to 18, of which 5 have been selected for the Milestone Prize accomplishment round. The 5 selected teams are Astrobotic and Moon Express from America, Indus from India, part-time scientists from Germany, and Hakuto from Japan. To reach this stage, the teams had to do 2 things. Define firstly what their critical technical risks are, and secondly, how they plan to overcome them. Teams have to demonstrate their technologies and prove to the judging panel that they've reached their milestones. Those 5 teams can share in the $6 million available if they demonstrate that they've overcome the specific challenges that they were selected for. Those challenges are spread across 3 technical areas: landing, mobility, and imaging. The lunar environment is incredibly harsh. There's extremes of temperature, radiation, the environment is a vacuum, there's highly abrasive lunar dust that gets into all of your equipment. The ways these small, privately funded teams will overcome these challenges will be incredible. The Milestone prizes run through till the end of September 2014. The 13 teams that weren't selected for the Milestone prizes are still eligible for the Grand Prize, the Second Place Prize, and the bonus prizes. The Google Lunar XPrize is pioneering the future of space exploration. We're going back to the moon, this time for good. Visit our website, googlelunarxprize.org, and follow along as these teams make history.
Now, that video was incorrect in one area. Then it said that the testing was supposed to end in September. It actually went a little bit long, and the test ran through December. I was lucky enough to go to a lot of those tests, and later this week we're going to be launching a video series showing highlights from a lot of those tests. But we'll show a teaser of that a little later. But right now, let's introduce our esteemed panel of guests. We've got representatives from all 5 of the Milestone teams, which is something I'm pretty excited about. You should be too. We're going to start with Moon Express. We've got Bob Richards here. Moon Express took home $1.25 million from these Milestone tests. Robert Bohm from Part-Time Scientists, German team, took home $750,000. Takeshi Hakamada from Team Hakuto in Japan, $500,000 milestone prize for his team. Rahul Narayan from Indus took home $1 million. And then John Thornton from Astrobotic, another American team, $1.75 million, the largest total amount for the Milestone teams. Now, this is a live discussion. We're going to get things going, but we definitely want you to take part and join in the discussion as well. You can hit us up on Twitter. I'm Tim_Stevens, or you can use the CNET Live hashtag if you like. You can also give us a call, 1-888-900-CNET. That's 2638 if you've got a numeric dial pad. Please give us a call, and we'll be going to your questions throughout the discussion. But right now, let's go ahead and start with a discussion at the high level of what exactly is XPrize. Bob, I know you're quite familiar with XPrize. Would you mind giving us a quick overview of what exactly the XPrize organization is and how it got started?
Sure, happy to do that. So XPrize is an incentive organization that's set up to incentivize taking on world challenges. So prizes are offered for very, very large concepts like landing on the moon, things that never have ever been tried before. And XPrize offers these prizes to incentivize and catalyze whole new industries. And in this case, we're hoping a whole new industry going back to the moon.
And of course, things started about 10 years ago with the Ansari XPrize, which ultimately spawned Virgin Galactic. But there have been a lot of other tests and a lot of other prizes as well from XPrize. Things for as diverse as cleaning up the ocean, education, creating even a tricorder to help people be a little bit easier diagnosed in developing nations, that sort of thing. So there's a lot of great stuff going on. We're here specifically to talk about the Google Lunar XPrize. We got a good introduction there about what the GLXP is, but effectively we're talking about a $30 million purse for teams to race to the moon. And so it's pretty exciting, and there's a lot of work that goes on in terms of trying to get to the moon. These tests have been split up into 3 basic categories, as we saw in that intro video, basically representing the 3 biggest challenges to these teams. 1, landing on the moon. 2, sending back high-definition video from the moon. And then the third, of course, is actually being able to cover 500 meters on the moon. So the tests that took place over the course of last year were broken into those 3 categories. And so let's talk a little bit about exactly how that's going to happen and how these teams are going to basically pull off this feat, that is getting back to the moon for good, as XPrize hopes. So again, Bob, we're going to start with you. Let's talk about Moon Express and how exactly you guys are going to take us to the moon. You've got a different approach than a lot of the other teams. Talk about your toroidal lander.
The donut.
I have a hard time saying toroidal.
Let's say
I don't
donut.
know why that. Let's say donut.
Let's
Much
say
better.
donut.
The flying donut. Tell us all about the flying donuts.
So, one of the hardest aspects of the Google Lunar XPrize is actually landing on the moon. That's really the key part of it. Only superpowers have ever landed on the moon before. Only the United States, the Soviet Union, and more recently China have soft landed on the moon. So all of the Google Lunar XPrize teams are taking on this challenge that have only been taken under superpower type financing and technologies. Our approach, Moon Express, was to design the smallest possible lander we could that could fly as a secondary on a rocket that was otherwise going to space to launch a satellite. That way we could keep our costs down of launching to space. But then our little hot rod, we call it the MX-1, can make it to the surface of the moon all the way from Earth orbit. And we've been flight testing our lander here down at the Kennedy Space Center to prove that we could have our guidance navigation control and our avionics and our propulsion systems, everything we're actually building in-house, with the exception of a few small components. So it's very vertically integrated, and our lander is going through our flight tests. In the next couple of months, we'll be going through our mobility and landing tests, and we're actually taking over a launch complex at Cape Canaveral called Launch Complex 36. We'll be doing the further testing that'll eventually land us on the moon. And I guess the key thing is our lander is our rover. That's really the difference here.
Right.
So we're going to fly. We're going to fly.
Instead of touching down and basically deploying something that will drive along the surface for 500 meters, you'll basically be taking off again and then landing a second time, right?
That's right. So there's many ways for it to transport yourself on other planets. We figured if we've got a vehicle that can actually land on the moon, we're going to take off and land again.
And doesn't that double one of the most difficult portions of the challenge, which is actually touching down on the moon? Now you have to do it twice?
In some ways, it's trying to do the most risky thing twice. But in other ways, if you've landed on the moon, you've solved that challenge. You've already done it once. And adding other systems like rovers, the rovers are great but they also add complexity. And so we chose to land our spacecraft, to fly it. And this proves out our long-term vision, which is about prospecting and looking for resources in the moon. So by being able to fly around the moon, we can go much farther distances much faster than if we had to actually rove with a vehicle on the surface.
Now, Robert, for part-time scientists, you're definitely talking about a rover in this situation. In fact, we were in Germany seeing you guys do some rover testing last year. Can you tell us about the approach for part-time scientists and a little bit about your team?
Yeah, of course. So we're a German-based team of scientists and engineers, and we're pretty much focused at first on the rover development. So I don't know why. Maybe it was the easiest thing for us to touch base on as engineers. So we looked at the system, and one thing that really came to mind is that we have found one of the critical items for our system, which was the energy supply in this case. So the size of the solar panel is something that we noticed really defined how our lunar mission has to be designed, how our rover had to be designed. And from there on, our system really developed into a state where it's currently at a level that it can be operating not indefinitely, but it can actually, it's not limited by a certain factor. So it's not something that, I don't know, drives on the moon for 500 meters and falls apart, but it could actually go on much further. And from there on, we started on really putting in as much, I would call it high technology as possible. So we used a lot of stuff that actually is current in the industry, but not in the space industry. And we tried to optimize it and make it possible to use in space. So one of the specialties of our team is actually radiation hardened electronics. So we really have a lot of stuff nowadays that we use every day that you have in modern cameras that help you to do like HD video compression or calculations, and which you can actually do if you have this technology available in space. You could actually do it right on the moon, and that's something that really, I don't know, gets us going to make this possible to do it in space instead of having to send all the data back, for example, to processing to Earth. And yeah, with having such technology available, you make things easier for future missions, and that's what gets us going.
So are you basically then using commercial hardware more or less for a lot of the imaging that's going on for part-time scientists?
I wouldn't say commercial. It's not the stuff that you get if you, I don't know, go to a supermarket and you buy a camera. It's not this kind of hardware. So for example, for the camera system, we have special optics which were developed by a company built for nuclear power plant monitoring. So they really have some way of being radiation hardened already. So it's not the average stuff around the corner, but we still modified it to be as lightweight and energy efficient as possible.
And then what's the communication protocols that you're using to get that data back to Earth at that point?
The protocols, in this case, the communication link itself is an X-band link, and something that we're trying as a demo unit in cooperation with a partner is a laser downlink as well. It's the same technology that has been used for a previous NASA mission, which I think they even got up to 622 megabits. I don't know if we were capable of getting this because from the surface it's always a different thing, but it's a very interesting technology demo.
And then what sort of resolution are you looking to broadcast back from the moon?
As we not as required, I would just to say as required by the prize in HD, but it's actually, of course, our goal to submit HD video material.
Great. All right, now, Takeshi, we were seeing some of your rovers in action in Japan not too long ago on the dunes outside Hamamatsu. Now, you're taking an interesting approach. You have rovers, but not just one rover, you have two rovers. Can you tell me a little bit about Team Hakuto and your dual rover approach?
Yes. Team Hakuto is just focused on rover development. We decided not to develop for landers. So our effort is only developing the rover, which is very small rovers. We are developing less than 10 kilograms rovers. We developed two. The first is 8 kilograms 4-foil rover, and second is 2-foiled 2 kilograms rover. We are trying to combine these two rovers into one dual rovers in order to explore the Skylight. Skylight is a potential access to the cave underneath the lunar surface. In order to explore that cave, we are going to down the small 2-foil rover into the cave. So
you're basically dropping the smaller robot, almost like on a bungee cord, almost down into a lunar cave. Is that right?
Yes, right.
Which sounds a little bit extreme. You're doing some extreme cave jumping on the moon, which is interesting. So these are basically tubes that are formed by lava on the moon. And what do you hope to find inside these tubes?
We don't know yet, but
Fair enough.
it is said that it has potential to the future lunar base. So we wanna first to try to get an image inside the hole.
So basically, the idea would be that astronauts in the future could move into these caves. Is that right?
Yes, right.
Now, you mentioned about 10 kilograms for both rovers. How does that compare to something like the Curiosity rover on Mars?
Well, in terms of weight, mass, it's much smaller than the Curiosity rover. It is said that the Curiosity rover weight more than around 1 ton. 1 ton.
A ton.
So,
oh wow. Okay.
yeah.
That's
So
very heavy rover.
compared to such a huge rover, we are developing very small 2 kilograms, 8 kilogram rover. In order to minimize such a mass, we are using the carbon fibers as a material and using the technology of the small companies in Japan.
And in case you're wondering, 10 kilograms is roughly 22 pounds, something like that in the U.S. It's certainly light enough to pick up. And they are very small rovers. I was able to pick them up myself when I was in Japan not that long ago. All right, so let's talk about Team Indus. Raul, can you walk me through the team that you've got there and what sort of tests you guys have been up to lately?
So we started off about almost 4 years ago. Started off as 4 people. We've now grown to a team size of almost 40 full-time engineers who work on this. We've been focused on the lander. That's the one piece that we've been working on for a very, very long time. For the specifically for the milestone, we built what is called as an environmental model of the lander itself. This, along with mass dummies, both formats, we simulated the spacecraft as it would be when it is launching with fuel on it, and we simulated the spacecraft as it would be when it is about to land on the surface of the moon, which is very little residual fuel left. We put the lander through vibration tests, that's again to simulate the launch, and then we put it through a drop test to simulate the conditions when it is going to touch down on the surface. We got some very encouraging results. All that result has now fed back into the design, so we're back to the drawing board to incorporate the lessons that we learned on material stresses, performance, behavior, so on and so forth, which will lead into the next lander model expected a little later this year.
And then who are you working with when it comes to actually launching and getting into space? Because that's a big part of the challenge, is actually getting off of the surface of the Earth. Getting to the moon is one thing, but getting off the Earth is the biggest challenge. How are you hoping to get off of Earth, as it were?
Right. So for us as a team, when we started off, we were very clear that we have an advantage of having a local launch provider. ISRO's launch program, PSLV is a medium lift rocket. They can send about 2.5 tons, 2,500 kgs to low Earth orbit. Sort of works well for us because this is a robotic mission. We don't need too much of payload when we're launching. Our initial orbit, which we've negotiated with ISRO right now, is apogee of 70,000 kilometers, and they are sending about a little over 600 kgs to that orbit.
Great. All right, John, certainly, last but certainly not least, let's talk Astrobotic. Now, you're a Carnegie Mellon-based team. Can you tell me a little bit about the team and how you are related to the university?
Sure. Astrobotic is a business that spun out of Carnegie Mellon back in 2007. We're partnered with Carnegie Mellon, and they were a great partner on these Milestone prizes. They're focusing on the mobility, while Astrobotic is focusing on the business of lunar delivery and also the lander. So together, we were a really great team in the Milestone prizes, and we'll fly together to the moon.
And certainly that seems to be paying off with having the largest single prize anyway, $1.75 million from basically all three tests basically you were successful in. It includes the imaging, the roving, and the landing itself. Now, we went to the Mojave Desert to see your landing systems in operation. That was basically on top of a lander from another company, is that right? So how is your lander coming along at this point?
That's right. So for the tests in the Mojave, we partnered with a company called Milestone. And they have a terrestrial test bed that flies in the Mojave.
And Milestone actually came out of an earlier XPrize, right?
That's right. That's right. Came out of the Northrop Grumman landing prize. So it was jumping, basically hopping, similar to the hopping approach that's going to the moon. So Milestone was a provider for the terrestrial test bed. What we did is we built the guidance, navigation, and control system that goes on top. It's a pair of stereo cameras and lasers, and that's essentially our astronaut at the sticks. So it's proving the guidance system, making sure that it can fly, making sure that it can navigate tough rocks and slopes and craters, make sure we have a nice safe landing down on the surface. So it was really a fantastic test in proving critical developments toward our landing system. So the vehicle went up to 250 meters and came down fully autonomously, identified rocks that we had simulated, and found a nice safe landing site. We were able to do that twice, and it's really a fantastic testament to the team. So the lander development itself is doing really well as well. We also did some propulsion testing in December. We did a hot fire of a attitude control thruster in the Mojave Desert as well. So it's lander's well in hand, and we're making great strides toward creating the first business to fly payloads to the surface of the moon.
And then we also got to see your rover in action at a quarry last year as well, which seemed like a pretty good place to test a rover.
Yeah, it's a fantastic place. It's a place called Lafarge. It's actually leftover steel, so it's called slag. It's a slag heap. It looks very lunar-like. So if you ever needed to fake a moon landing, it's a not bad place. So we went there and we tested our rover, had our lander out as well. We did rover deployments. The rover went out and tested its cameras as well to make sure that the quality is up to spec.
And we all had very snazzy cowboy hard hats at the time.
That was the best part.
It was the
best
best
cowboy
part.
pads.
Very good investment.
So yeah, we're really thrilled with the outcome. Carnegie Mellon did some absolutely amazing work, and the team there really came through in all aspects. So this just to come home with all three landing, mobility, and imaging prizes is really a testament to the team, and really it's a fantastic reflection of a team working well.
Awesome. Well, we've got our first caller, so I want to go ahead and make sure we don't keep them waiting too long. Again, if you want to join us by the phone, you can give us a call at 1-888-900-CNET. We've got Ian on the line one. Ian, what's your question? Uh-oh, we had Ian on line one. Ian, are you there?
Yes.
Can you give us your question, please?
My question is how your technology can link to. Yes. My question is that how this technology can actually allow normal people to travel to space in the future.
All right, so how are we basically progressing the idea of space tourism, and how is this really helping us along, and ultimately, I guess, lowering the cost would be the big question. John, I see you nodding over there. How are we progressing in that regard?
Sure. So this is just the beginning. This is about sending robots and increasing the capacity to actually connect your humans to the moon. What we are seeing right now is a big drop in the launch costs. So this is access to space. And a lot of the teams here are building on top of that cost reduction to actually make the connection all the way to the moon. So this is opening the pathways. This is the first steps towards the moon commercially. And that's potentially creating the moon as the next continent of the world. So we're actually, on our first mission, we're actually offering the ability for people around the world through a program called Moon Mail to send a piece of them, to send a memento or something very important to them along with our lander, and we can land people's things on the surface of the moon. So it's the very first time that an individual can do that.
If I have a very heavy memento, would that be allowed, or does it have to be a lightweight memento?
It is it's volume constrained, so it's
volume. Okay.
It fits at ships. So you buy a container
Sounds
and,
like the USPS.
ship whatever you want.
Perfect.
That's
We'll
exactly
put it in
it.
a little blue box. We'll be all good.
Yep. So it's just the beginning.
And Bob, I know you've got a lot of plans at Moon Express for long-term moon access as well.
Well, yes, Ian asked a great question. I mean, I want to go to the moon myself. I think it's something
all
that
do.
we can do in our lifetime for sure. But as John says, these are baby steps. We're sending robotic landers, but we'll be able to do a lot with these robotic emissaries, especially with new technologies. We can immerse ourselves very much in the experience of being on the moon. Moon Express, for instance, will be sending a telescope, kind of a moon cam to the camera, that all of us will be able to access through the internet. It's through the International Lunar Observatory Association. So everybody, it's democratizing access to views from the moon back to Earth and to the cosmos that have only been seen by a handful of human beings. And we'll be able to get that to everyone on the planet to tie into that amazing experience over the internet. And we'll do other cool things too, but eventually we want to go there ourselves.
Yeah, I mean, I definitely want to go. And I know that the biggest challenge right now is cost and getting off of Earth and escaping our gravity. And I know that these sorts of costs are not exactly very well openly discussed because there are a lot of contracts involved and NDAs and that sort of thing. But can any of you give me an idea of what it would cost me if I wanted to just blast myself into space, and have my Major Tom moment, no lander, no rover, just, let's say, just me.
Do you want to come back?
No, I don't have to come back. I'll just go floating off into space, and my spaceship will know which way to go, and we'll be fine. How much would it cost me to get off Earth to get
Well,
out
if you're going to buy
as cargo?
if you're going to buy your own rocket and just ride in your own rocket, it's going to cost you $60 or $70 million if it's SpaceX, or something over $100 million.
And if I'm
it's
sharing
something else.
space with somebody else?
Yeah, if you're sharing space with somebody else, like we want to do, you want to get that down to maybe $10 million or something like that. But it's not cheap to get into space. But once you're in space, the good thing is you can get almost anywhere from there.
Yeah, Robert.
Okay, but you have to differentiate a little bit about what you mentioned is that you want to do human spaceflight. And I think there's a big difference between sending robots to space, which is, compared to human spaceflight, much more easier.
Sure.
Because you can use launch vehicles which are actually quite cheaper. So, for example, the specific thing about our mission design is that we focused on satellite launch vehicles instead of the larger ones like the Falcon 9, which is really it's a great launch vehicle, but it's really huge in its capacity means. And also, of course, with the price tag, which makes sense because it's a larger rocket. So if you would yourself climb into a satellite launch vehicle, then you would probably not survive the launch because of the extreme forces that apply to it. But it would be cheaper.
I mean, are we still talking tens of millions of dollars, or are we getting down to?
Yeah. Okay. I don't know. Okay. Dollar and euro is almost 1-to-1, so we're talking like 20 to 30 million.
So now we're talking about a $30 million purse here. So where's the incentive then? I mean, because ultimately all of you are going to be spending more than that probably just to get to the moon. So where does the incentive come in?
So the good news is there's a $30 million purse offered by Google. The challenge is, of course, it's going to cost a lot more than that to actually get to the moon. So the X Prize is always about opening up a new catalytic idea for a new industry. So you have to come up with a business case or some reason why you would go to your sponsors, your investors, and they'd part with their money and help you get to the moon. And in Moon Express's case, our investors are interested in the long-term value of the moon, of the potential of lunar resources, both to our future in space and to benefit life here on Earth. And in the near term, we're going to be offering transportation services to the moon and be able to deliver payloads and cargo. And we're currently partnered with NASA to help the United States get back to the surface of the moon with the robotic explorers and look for those valuable resources that could be a complete game changer for all of us here on planet Earth and for exploration of space.
And how much of your time, guys, is spent raising money versus engineering? I mean, which is the bigger challenge, I guess, raising the funds or figuring out the engineering, John?
I think the biggest challenge for everyone is raising the funds. It's really a race to see who can get the most money put together. So our approach is to offer a business, to offer a service, to fly payloads to the moon. So our approach is to bring payloads together from around the world that want to fly. And we mix that with some investment and some technology contracts, and that's the way we fund our developments. So really, it's a race to see who can get to that first metric of having the launch and getting to flight and going all the way to the moon.
All right, we have another caller on line 3. Keenan, I believe it is. Are you there? Uh-oh. There we go.
There we go.
Keenan, are you there? Do you have a question for our esteemed group of panelists?
Hello?
Hello. You are live on
hi.
CNET. How are you doing?
I was wondering about how long are these rovers expected to last past their 500-meter mission?
Robert, you mentioned before that you were hoping to go much longer than 500 meters. Roughly how long are you hoping to last?
The design, the maximum time would be 1 lunar day, which is just 14.5 days. So the reason why I'm mentioning this, the operation time on the surface for our lunar rover is 11.5 days. And it's technically capable, of course, working more lunar day intervals, but it has to, let's call it hibernate. Actually, it's just shutting down for the lunar night. And the issues that we currently see is for the batteries to survive the lunar night. If the batteries hold, and it looks promising, but there's really not so much of a guarantee there, if they hold, as long as they hold, then it can always work on lunar day intervals.
What sort of temperature swings are we talking about here? Because it gets very, very, very cold on the moon at night.
It goes down to, 300 degrees Fahrenheit or 220 or whatever that is Celsius. So the swings are many hundreds of degrees. And as our Chinese friends found out during the first lunar night, their rover kind of froze. We at Moon Express are planning in our first mission that 1 lunar day, that 2 weeks only. But in our second mission, which will be a couple of years later, we're planning to go to the lunar South Pole and try to find one of those peaks of eternal light. Not quite eternal, but where the sunshine shines a lot. And we could increase the longevity of our equipment on the moon for months or perhaps years.
And Takeshi, your rovers are quite a bit smaller than some of the other ones. How long would you hope that your rovers might survive?
Our rovers estimated to operate during 2 or 3 days on the lunar surface. We're gonna
Earth days we're talking, right?
well,
72 hours, is that roughly?
2 or 3 days.
Okay.
Internal battery can endure several hours, and we estimate just driving 500 meters will take just 2 to 3 hours. So there will be enough time to do some other missions.
And well, I mean, you're talking about the skylight viewing. Is there anything else on the moon that you're hoping to check out while you're up there?
Not yet. The skylight is our main missions right now.
Great. All right, so we got a bunch of other questions coming on Twitter and Reddit and all sorts of other places. Again, you can tweet at us. CNET Live is the hashtag, or you can tweet at me directly, Tim_Stevens. Again, if you want to call us, 888-900-CNET. And thank you, Keenan, for that last question. That was great. Elsa Kerman on Reddit, actually, this one is a good question for you, Bob, because of this is relating to the construction of the flying donut we were discussing earlier. Why is the exhaust invisible for hydrogen peroxide? Now, your lander is powered by hydrogen peroxide largely. Why is that invisible?
Well, right. So The only time that the exhaust is actually visible, as you saw in the video, is right at the very beginning when the ignition sequence is just heating up the catalyst beds as the hydrogen peroxide heats up, it becomes superheated steam and therefore visible. So when you see the lander flying, that's actually the exhaust is completely invisible superheated steam. Only at the beginning can you see the those kind of pulses of steam. So our donut, our MX-1, is actually kind of a steam engine that's going to the moon. And one of the reasons we've chosen hydrogen peroxide is that the constituents of H2P or hydrogen peroxide, H2O2 are hydrogen and oxygen. So the elements of hydrogen and oxygen are also available on the moon in the form of water. So H2O on the moon is kind of rocket fuel that is the game changer, not just for the economics of the moon, but we believe the whole solar system.
And you can also go down to the grocery store and buy it really easy too. That helps, right?
Right. That potion that you get at the grocery store of hydrogen peroxide is about 3%. I wouldn't recommend putting our rocket fuel hydrogen peroxide in your hair. Running around with your hair on fire would be literally true at that point.
So I'm safe walking down the aisle at the grocery store if I go about hydrogen peroxide. I don't have to worry about it
That's
blasting me to the moon or anything
That's
like that.
correct. Yes.
All right, we've got Alex Hall in Twitter. What difference will Milestone wins make for teams in their efforts to find a launch before the end of 2015? Raul, how is this additional funding that we're getting kind of along the way helping out? And I guess maybe I should clarify. So the end of the Google Lunar XPrize is effectively the end of 2016 formally. That is, a team has to be on the moon by then. But any of these teams have to announce a launch partner, i.e. a way to get into space by the end of this year, the end of 2015. So they've got until the end of next year to get on the moon, but they've got until the end of this year to basically sign the contract and say we're going to blast off before the end of next year. So how is Team Indus, and how is this funding that you're getting now as part of the Milestone prizes, how is it helping you guys along?
Yeah, so hi Alex. I think for me, this has been I mentioned that before, it's been a 4-year journey. It starts with a bunch of guys saying we want to do this. You go out there and tell people that, you use private funds to build something that's going to land on the moon. And, that's a bit of a stretch. As you continue building technologies, as you continue demonstrating the fact that you've been able to reduce risk and you've got something now which is, working towards, getting ready for flight. So it's a progressive credibility thing. So for Team Indus, what the Milestone Prize does is there's a little bit of money, which is great, but I think it adds to the credibility, it adds to our story, and we are able to take this back to everybody, to partners, investors, even potential hires, to say that we're headed in the right direction. We're up there with the best, and quite like any other business, you'll have to fight your way. But we use this opportunity to say we head in the right direction, and we have a good chance of making it for the grand prize.
And the visibility that XPrize and that Google offer in this case is a big part of the discussion and the factor, right? Robert, would you guys be doing this anyway if the Google Lunar XPrize didn't exist?
I have to admit, no, we wouldn't be doing it because, I don't know, the GLXP really inspired me to, get this team started and try to build a mission that gets to the moon. So really, I was just had in one day, just doing the work there, I got an email from a friend which posted me the press release of the Google Lunar XPrize, and I was like, wow, why is Google doing this? And this thinking really got me started about, why was actually somebody putting money down to offer a prize towards getting to the moon? And this was really this question itself was the exciting thing. And then, of course, finding the answer.
And actually, that's a fair question. That's a question that I get a lot, actually. Why is Google doing this? Why is Google putting up the money? Anybody want to take a stab? I know we don't have a Google representative here, but I think you can probably guess.
So we're not Google, but we've talked to Google a lot. We love Google. Google is very interested in inspiring the impossible. So the audacity to think that a small team could actually reach the moon is something that I know Google would hope would inspire a whole new generation of mathematicians and engineers and scientists and the public interested in looking up instead of just down. So it's a very cool thing to do, and it will lead to a whole new world. It'll redefine the possible, and I think that's one of the things that Google's very interested in doing.
I certainly am looking forward to having the possible redefined as well, absolutely. All right, a lot of more questions coming in. Andy on Twitter is asking, what has been the most challenging aspect of the Lunar XPrize journey so far? John, what's been the biggest challenge for you guys so far? I mean, we talked about funding before. Obviously, that's been a big challenge. But from a technical standpoint, what's been the biggest challenge?
There's been a lot of big challenges through the course. Funding is a big one, but aside from that, the technical challenges, what we found is the biggest challenges is the guidance, navigation, and control system, and that's why we started with that first, and we went after the hardest problem. So the challenge there is that you're coming in at a very fast velocity coming down to the moon. You don't have GPS, so a lot of the UAVs and helicopters and planes here on Earth can land using GPS. But there's no GPS on the moon, so you have to have a whole different guidance system that can determine your altitude, determine your location. So we created a system that uses image mapping. So it's much like going out on a hike and you look at your terrain map and you say, oh, there's a river, there's a stream, there's a mountain, and I'm about here relative to those features. So the same thing is happening on board live, the spacecraft, and it's autonomously figuring out where it is through space as it's coming down for the landing. So that's been a particularly challenging aspect for us. We did prove it twice in the desert. So the next step for us is we're going to be looking at propulsion system quite a bit. But really that autonomy and the robotics solution for us was the one that we wanted to hit off first.
Well, I totally agree with John on that. We took on that same challenge as well, the guidance, navigation, and control. 2 years ago, we flew our GNC software on the NASA Mighty Eagle platform, and both in open loop and closed loop, and showed that we could be mobile and land. And that really de-risked, lowered the risk of us putting in the investment of building our own hardware, which we've since done, and you saw that hardware flying down at Kennedy Space Center. And like John says, now we're really focused on our propulsion. And although you do see some of our rocket engines firing and flying our vehicle, the rocket engines that will be flying in space are a bipropellant that uses not just hydrogen peroxide, but also a kerosene injection to give it the boost it needs to get out of Earth orbit, to slow it down and to help it land on the moon. So there's still a lot of development on propulsion for us, and that's one of the reasons why we're moving into our own launch complex at Cape Canaveral over the next few months, where we can develop those rocket engines and do those test flights.
Yeah, I was lucky enough to get a tour inside of SLC-36, which was pretty exciting, I must say. It was a little bit scary with no lights and no power, and walking into a room that I felt like nobody had been in since the 60s. But a pretty exciting place. So 80 acres of land right at Kennedy Space Center, is right next to where the Orion launch was at the end of last year. And you got a lot of plans there for rocket engine tests and landing pads, that sort of thing?
We do. It's a fixer-upper, as you say. But
a historic fixer-upper.
It's a very historic.
And the location is good as you
beachfront property, 80 acres on Florida. You can't complain about that. Mm-hmm. But it is the site, as far as the history goes, where the United States first launched its robotic explorers to the moon. So the first probes to the moon, the surveyors, they all launched from Space Launch Complex 36. So it's a real honor to be able to now be the custodians of this launch complex, and as a commercial company, invest in refurbishing it, and in partnership with Space Florida and Kennedy Space Center and the 45th Air Force Wing to reinvigorate it and to again have landers and rocket engines firing at that great facility, and one day will help us get back to the moon.
Right. Questions are coming in quick on Twitter, which is great. Again, you can send us, if you like, CNET Live, if you like, as the hashtag, or again, you can give us a call at 1-888-900-CNET, which is 2638. Another question from Alex Hall on Twitter. What was the most nerve-wracking moment during your GLXP milestone tests? Takeshi, what was your most nerve-wracking moment during the testing? When were you most scared or worried?
During the development of our rover, we faced some of the difficulty. We lost our electronics during the experiment, and we need to refine the deployment mechanism. Such a thing was a difficulty for us to overcome. But finally, we've already overcome this kind of the program, so we are ready for the moon right now.
And it certainly had some weather issues, as I recall, too, during the testing on Hakuto. It was very strong winds and very, very cold, and that was I was pretty cold anyway. I'm guessing the rover was cold
another
too.
issue.
Probably
at
not
the time.
lunar surface cold, but it was too cold for me. Robert, how about you?
The most nerve-wracking thing at least from my perspective, as not being the engineer involved in the development itself, was actually the vibration testings. Because, I don't know, it's one of the tests where you don't see that much, but where actually, at least from a personal feeling, you know that a whole lot of things can go wrong. You know, you have like a lunar rover which is working before the test, and then you're applying the launch loads to it, and then this moment when somebody pushed the button to start the test program to see if it still works after applying all those loads, that's really, I don't know, challenging.
Can you walk us through that test a little bit more? How do you do vibration testing? Do you strap it to one of those novelty beds and put it in a quarter, or is there something more scientific involved?
ADS is a little bit more scientific. So you have
Good to hear.
a vibration test bed in this case, and one thing that we needed to do is to build a special frame which simulates the way that, for example, the rover or the camera system is connected to the rocket itself, which has all these loads meaning, I don't know, the forces being applied, for example, during launch, or for example, the shocks that you have, shocks for example, some separation. Or the certain thing we have to understand in our case is that we are launching with, we're going to design everything to launch with the Russian Dnieper rocket, which is a former intercontinental missile, and it really is one of the hardest launch vehicles. So it has one of the worst launch profiles that you can think of. So in comparison, launching with a Falcon rocket is really a nice and smooth ride to this.
And John, is that something that would be a little bit easier if you were, say, flying on SpaceX or something like that?
I think it's a little bit of a softer ride than the Dnieper ride. I don't know the numbers off the top of my head, but the vibration environment is pretty challenging. It's about 8 Gs pushing you down in your seat and getting shaken, probably the strongest earthquake you could imagine. So really, it's
Sounds
a
like
game
fun.
of making your spacecraft stiffer than the launch vehicle. Because if you align with those same frequencies and get matching, you can shake your spacecraft apart, and it's a big challenge. So this is something that we tackled a couple of years ago when we built our lander structure. And we were able to do vertical and horizontal shake testing at it. It is pretty nerve-wracking to see that thing go up and hear the noises that come out of that.
And it'd be a real shame to put all the investment into the engineering and have it fall apart on takeoff. That'd be a real shame. All right, Peter Griffin on Twitter, a question for Team Indus. How tough or easy is it to collaborate with a government organization like ISRO, which you'll be doing?
Okay.
That's for you, Raul.
Yeah. So government organizations in India are not familiar with the paradigm that you have, let's say, in the United States, and we did have to go around, inform them of what's happening, make them familiar with the Google Lunar XPrize, tell them that we're a serious team, demonstrate that we're a serious team, put up the money for the testing that we did. But with ISRO, our original office was in Delhi, then we moved to Bangalore to be close to ISRO, and now we've been working very, very closely with them for 2 years. It's worked out well for us. We did our vibration testing for the lander inside our ISRO facility, and drop test inside NAL, that's National Aerospace Labs. So it's been a learning journey, but I think now when these government entities see that you're being serious about it and there is true technology being built or progress being made, they align very well with you, and that's been a great experience.
And we should be clear that while it is okay to collaborate with governments, these are ultimately commercially funded or privately funded efforts, right, Bob? You've done some partnerships with NASA, gotten a little bit of information from them, right? But ultimately, NASA's not writing the checks to get you off the surface. Is that right?
So that's right. So to emphasize your point about the rules of the Google Lunar XPrize, a cap of 10% is allowed of what you would call government subsidy, where a government is just kind of giving you something, a grant. Or in the case of Moon Express, and we have a partnership with NASA. We've had one for some time, as does Astrobotic. First under something called the Innovative Lunar Demonstrations Data Program, where NASA is interested in buying data from us. So it's a commercial proposition. There's value for value there, and it's not a grant of any kind. And all the risk to get the data is on the private player. So we have to get the data first, and if NASA likes it, then they will buy it. So there's no guarantees. But more recently, the Lunar Catalyst program of NASA, which is really a true partnership of value for value. It's a no exchange of funds right now, which means we're not paying NASA and NASA's not paying us, but we're benefiting from in-kind of technology and of data, of resources, and in response, NASA gets insight into what we're doing. But there's also a third vehicle that Moon Express has at least been using, which is called a Reimbursable Space Act Agreement, which is a unique instrument that allows us to contract with NASA and to pay NASA for actual access to the resources, which has been very useful to us to learn from NASA, not only to stand on the shoulders of giants that have done this before, but to work shoulder to shoulder with those giants and learn from them so our team of 50 engineers can be the ones that are in the driver's seat in the future.
And that for me is actually pretty encouraging because touring Kennedy Space Center last year was a little bit depressing to see all the space shuttle hardware being ripped out and torn down, and that seemed like a lot of legacy being lost. But ultimately, this sounds like a lot of the information that's been learned by NASA over the past 50-odd years is still being conveyed on and helping the teams move forward. Is that right? That is encouraging.
That's right, and there's a transformation taking place at many NASA centers. At NASA Ames, where we're headquartered, we couldn't do this without NASA, and the innovation that's out there. And at Kennedy Space Center, as you say, there's not any shuttle landings. You can look at the sky forever. There's not another shuttle coming. But there's a complete awareness that the transformation to commercial partnerships, which is handled down there by an organization called Space Florida, is very important. And for us to be able to announce last week that we're actually creating new jobs in space around the area was very welcomed.
John, how's the assistance coming from NASA been for your team in terms of the knowledge that you're getting and the help that you're getting from them? Has that been very helpful for you as well?
Yeah, our partnership with NASA is very strong. It's between Catalyst and ILDD. It's been really fantastic. So we have some of the best landing engineers in the world from NASA that are working on our lander and helping us create and really create the dream of having a reproducible, commercial, viable launch to the surface of the moon. So it's really fantastic to leverage that skill. It saves us a lot of effort and time, and we can learn from the best.
All right, so let's go around the room because we ultimately were wrapping up this milestone phase, which was kind of an interim phase to give some of you guys a bit of a cash injection to help you guys through and to make sure that everything is moving along for a hopeful launch in 2015 or 2016. What's next? What's the next step for your testing? What's the next step for your launch? And how far away are you from, let's say, signing a contract with somebody who owns a lot of big rockets? Bob, we'll start with you.
Sure.
For Moon Express, what's the next big step?
Sure, the cash is great, and we are very appreciative of the recognition from XPrize Foundation. What we're undertaking is something that costs on the order of $50 million to send our robot to the moon, and we've raised the majority of that already. So what we're after right now is a few customers to get those contracts closed, and ultimately to win the Google Lunar XPrize, which will be the icing on the cake for us. The next thing is what we're doing right now. We're continuing our testing of our lunar lander down at the Kennedy Space Center for the next couple of months, and fine-tuning everything that we're learning. And then we'll be transferring all of those operations, including our production of our propulsion and all of our facilities in Huntsville. We're transferring those down to Cape Canaveral, where we'll be moving into Space Complex, Launch Complex 36. We've had a launch contract in the past. Things change in the launch industry, and we're negotiating with several opportunities right now, and we certainly expect to be able to announce that in the next few months, certainly by the end of the year, that we have a launch contract. And once we have that in place, look out, we're on the way to the moon.
There's a launch company moving in right next door to you down at Kennedy, right? But
it's not a bad place to be when you want to go to the moon, is at Cape Canaveral and Kennedy Space Center. That's right.
Robert, what's next for part-time scientists?
For us, it's speaking from a schedule point of view, the next thing is finalizing the rover design. Even though we won the Milestone prize for the rover, it's still not 100% final. So there's still some things to do. We've got a lot of learnings out of the milestones that we want to incorporate into the next design and make it a full flight-ready version. And another thing is that something that we're really happy about, that end of last year we finished our very first lander prototype. And a lot of the development after finalizing the rover till mid of this year will be towards iterating this lander prototype. The issue with building landers is that with our rovers, we have many prototypes of many generations, and you can always build a new one to test a certain thing. But with landers, it's just like, I don't know, you will actually maybe end up just having like 2 prototypes in total because the hardware is so expensive and not easy to build.
If it were easy, we'd all be going to the moon. Takeshi, what's next for Hakuto?
For Hakuto, because we are only developing rover, we have to find the partner for the lander. So we're gonna announce the lander partner in a couple of months. So And for funding, we are still looking for the additional funding. We've already raised several $1 million. However, we are looking for the another $1 million.
So if anybody has $1 million lying around that they'd like to send to Takeshi, do you have a phone number that you'd like to give? For the
Yeah.
Are you taking credit cards? Now, we should clarify what you just said, because ultimately you're developing 2 rovers to go to the moon, but ultimately not the landing system and the launch system itself. Is that right? So you're looking to partner with somebody else to get to the moon in the first place?
Right.
But you're not willing to tell us who that partner might be? At this point?
Not yet. We are negotiating with several partners, potential partners. We're gonna announce probably soon.
Probably soon. Oh, I hope you'll let me know when you do announce. What's next for Team Indus? What are you guys up to now?
We've had this T-minus 18-month plan on hold for a very, very long time. And we raised a little bit of money towards the end of last year, a little bit of money that comes in from Milestone. I think we'll get rolling with that. So the plan is there. The configuration is complete. The supplier, the supply chain is tied up, so to say. So from the time that we do put in advances to procure space grid hardware, it is an 18-month journey from there. On the launch, we have not approached anybody other than ISRO, and that's how we intend for it to be. ISRO has been fairly cooperative, and in terms of sharing data, in terms of sharing launch windows, so we'll continue working with them. We don't have a time frame on when we could potentially announce a launch, but we do hope to do it within this year.
So if you have another $1 million you're looking to donate, we have a source for you.
Just tweet to us. We'll tell you where to send the check.
Are Bitcoins accepted?
Yeah.
Any form of currency you like.
Yeah,
John,
absolutely.
What's next for you guys at Astrobotic?
Our focus is continuing to build the lunar delivery payload commercial service. So we've got 5 contracts toward mission 1 already. We recently launched Moonmail, so now individuals from around the world can actually fly. They can log on to moonmail.co and actually send a piece of themselves, a memento to the surface of the moon. So we're continuing to push these sales. We actually anticipate some payload partnership announcements coming up in the next couple months, so stay tuned. That's our focus, and we're going to be building some propulsion systems this year, and continuing toward the march toward flight. So we're really excited and looking forward to flying the first commercial payload service to the moon.
Another question from Twitter, which I think is a good one. Now, there are 18 total teams that are still in the running for the Google Lunar XPrize, at least last time I counted. So 5 of you were eligible for the Milestone prizes and took home some money. That still leaves 13 other teams. Are any of them that you're keeping your eye on? John, is there any other team out there that you're keeping your eye on at this point?
I think the one you have to keep an eye on is Space IL out of Israel. They're very well funded. They've got some really great people working with them, and they've got a lot of the right ingredients to make a mission go. So of the other teams, they'd be the one to keep an eye on.
Yeah, I agree. Space IL.
Space IL. All right. Well, if Space IL, you just got a vote of confidence there, and I'm sure.
So, and I'd say it's anyone's race, and don't with your Take Prize and the Spirit of St. Louis was really the underdog back when Charles Lindbergh first flew. He wasn't the favorite. So although we have great momentum here at Moon Express, and you're seeing 5 of the Terrestrial Milestone Prize teams here today, the Terrestrial Milestone Prizes weren't competition against each other. That's very important to know. This is not a competition against each other. This was a competition against ourselves. We're the ones that defined what was hard for us. And that's why the reasons we're here today taking some of these prizes. All of those other teams out there still have very viable ideas. And the fact that they didn't participate in these prizes doesn't mean that they're down and out.
All right, we're almost out of time here, and I was lucky enough to visit most of you guys in testing. I'm sorry I was not able to make it out to India due to some visa issues. My apologies. But I was able to see a lot of the tests that were in action, and we've got a video series coming up later this week that's going to be launching, giving some overviews of all the excitement of rockets blasting off and rovers roving and all that good stuff. And I wanted to give you a preview of what's coming up, so take a look. But that was the ultimate tease because I'm not going to show you anything. You're just going to have to come back to cnet.com a little later and see it for yourself. But you can definitely check out all of our coverage continuing of the Google Lunar XPrize at cnet.com/GLXP. And tonight, you guys have got some festivities going on here. We're going to be handing out some big checks from some Google representatives. Everyone going to be dressing snazzily for this evening. Everybody excited?
Totally.
All right. Well, I'm going to be there, and I'm excited myself. Gentlemen, thank you all for joining us, for flying in from all over the world. All five of the Milestone winning teams. It's great to have you here. And again, thank you very much. Good luck on all of your efforts. And again, if anybody's got any large checks that they want to distribute, I'm sure we've got some willing hands in the room. Thank you, everybody, for tuning in and watching us. Thanks for all your great questions and all of your calls. And we'll see you next time, maybe from the moon. Maybe. Could happen.
Thanks.